And before going to start that thing, we have a offer that we are providing complete front-end functional design verification training program, right? Which include digital electronics, Verilog, system Verilog, UVM, Python scripting, test bench integration with Python, and with 3 industry level projects. So here Verilog is the HDL language, means hardware description language. So whatever we can implement in the digital electronics will write a code, a design code inside Verilog to synthesize that design, right? After that, next language is system Verilog, which is hardware verification language. We can verify that design using that language. Next one is UVM, that is a methodology, universal verification methodology. Same Verilog code can be verified with the help of UVM. After that, well-known Python scripting. Nowadays, guys, it is very demand. It is in a very demand, right? It is using with AI, ML, and all. So it is, very efficient language, right? After that, how we can integrate the Python with the UVM. That's a very important thing and very new thing provided by us, right? After that, 3 level, industry level project. They will related to Verilog, system Verilog, UVM, and Python, means Python integration with UVM. So guys, here in this training program, we will learn the languages like Verilog, system Verilog, UVM, Python, and everything from scratch. If you don't know anything about the programming, no need to bother about that. I am here to teach you all these things, right? Again, what is the key features of our training program? So first one is live training program, right? So it will be a live training program, and one-to-one training program means only one student will be there. Real time doubt clearance. Suppose I am describing some topic. If you have doubt, you can interrupt meanwhile and you can ask your query, right? No recorded videos, because many training institutes, they have pre-recorded videos and they share the student. Nothing like that. It is totally scam. So we'll give you, live training, the fresh training. The next thing is topic wise assignments. Let's say I have completed one topic. After that, I will give you some questions so that you can practice them. And if you stuck somewhere and if you have some doubts, you can ask me in next session, right? Again, next one is mock written test and interviews. So after doing that, we'll able to know that what is your weak points, where you are leading or where you are lacking, so that we can improve that. We will work on that and can improve on that. And next point is student no need to write anything. Means if I am giving you training, so you means you no need to carry any copy pen, any kind of things. So I will provide you the soft copy of the notes, which includes theory as well as the programming and code, right? So your work is only to focus what I am telling, what I am teaching, my approach and all. Flexible timings over weekends. So if you are working in some another domain, or even you are working VLSI domain, and if you want to, some flexible timings, so we are available over weekends at every Saturday and Sunday, right? So this training program useful for fresher as well as the professionals, because some professional want to improve their skills, enhance their skills, so it will be helpful for them, right? The next thing is fee can be paid in the installments, so you no need to pay all the fee in advance or something, nothing like that. You can pay in installments, right? And guys, if you are interested or if you have any kind of query, you can WhatsApp me on the given number, that is 99976 15007, right? And yeah, guys, if you want any kind of demo or something, so that is freely available. So you can ping me over the same number and ask for any demo session. That is totally free of cost. Fine. So guys, today we will discuss about basics of PCI based system. Fine. So first of all, we need to draw a block diagram. Here will be a block, one another block. Okay, let's reduce the size of this thing. Here we need a bus. One more block. Some slots. Bidirectional. Again, we need few blocks. Connections. Now we need some labeling. Right. So that is processor. That is called North Bridge. That is graphics. These are HDRAMs. Some slots. That is called SCSI. It is our Ethernet. That is South Bridge. That is something called IDE. That is some interface towards some CD, hard disk. Again, that is also IDE. That is ISA. That is called Super IO. Input outputs. That something like some boot ROM. That is some chip, some audio chips, and what else? Okay, so here will be some ports, some mouse for keyboard, some floppy in old generation system, some another floppy 2 or something, right? That is a bus called PCI at 33 megahertz. Fine. South Bridge Ethernet is there, CSI is there, slots are there, HDRAMs, processor. That's it. Now we will discuss about each and every block. What is the structure, what is the need of that block, and all. We will discuss each and everything. Fine. So as you can see, if you see some geographical map, so it will be your east side. It will be west. It is north side and it is south side. Hence, they give the name North Bridge at north side and South Bridge is situated at south side. Fine. Now we will discuss the theory and the working model. First of all, North Bridge. So it is a high speed data management hub. Second point is main function of North Bridge is to manage communication between processor and the parts of the motherboard. Also known as controller hub. Fine. Or one name is also there, host bridge. The next point is it connect to processor. We can also say CPU via FSB. FSB bus, that is called front side bus. Next point is also connects with graphics card, or you can say GPU. Both are same actually. HDRAM, that is memory, and South Bridge for further connectivity. Next point is manage communication between the CPU or processor, memory, and GPU. It handles high performance component. Fine. So it is all about the North Bridge. Fine. So let's understand the diagram. Here you can see, guys, that is the processor, or we can say the CPU. Fine. So that is the North Bridge, right? So as I mentioned, the first point, it high speed data management hub. So all the things are connected over here, whether the processor, CPU, graphics card, or HDRAM, they all are very high speed devices, right? Graphics card is also known as GPU, right? Graphical processing unit, right? So these all things are connected together, and all the things, all the data management over here will be taken care by the North Bridge, right? And that is something called FSB, right? Front side bus. So where it is? Here it should be actually FSB. So the connection between the processor and the North Bridge is by a FSB bus. Fine. Now coming to the next point, that is South Bridge. Manage lower speed peripherals. Next point is main function of South Bridge is to control the IO functions. Next point is the North Bridge is the medium that connect South Bridge and CPU, also known as IO controller hub. Fine. it connects to IDE devices like HDD, hard disk, or CD, USB ports, ISA bus, Ethernet, and SCSI controllers. Next point is manage input output function, data flow, and from slower device. Fine. Now coming to the diagram, here is your south bridge. Fine. So actually it is connected to CPU by a north bridge, right? And it is also connected with the SCSI by Ethernet, right? Some boot ROM, all these things. Super IOs means keyboard, they all are the low speed devices. So it will take care of the data management of the IOs operation as well as the low speed devices, right? It is also known as IO controller hub. Fine. We will see later that what is IDE, what is SCSI. We will take care of all of these things. Fine. So the next point is some little bit about the CPU. Few lines. Processor. Central processing unit. Executes instructions. Connected via FSB to North Bridge for high speed communication. Now coming to the point, what is FSB? FSB stand for front side bus, right? Now the next point is graphics. Graphics. It is basically GPU, or there is something called AGP slot, right? Older system. Means old generation PCs. So what AGP stand for? Accelerated graphics port. A dedicated port for graphics card developed by Intel in late 90s. Now coming to main point, graphics connected to North Bridge to allow high speed data transfer for graphics rendering. Fine. Coming to the diagram. So here you can see the graphics, right? So here the graphics is there, so it is connected to the North Bridge. Fine. So the purpose was means let's say in your mobile and in your laptop also you have one audio, 1 minute audio, and you have a 1 minute video. So you always compare the things. If you extract, let's say you only have one video with voice as well as the images, right? So if you extract the audio from that file, so one become audio file, another one will become video file, so you can compare the size, right? So video size will be much higher than the audio size. So because it is a huge size of data, so we need the fast operation. That's why we connected the graphics card to the North Bridge, right? Because it perform high speed operation, because it is just nearby to the CPU. Fine. And one thing is also there here, should be something called here USB port. USB. Fine. So now coming to next point. Let's take RAM, HT RAM. So it is just some memory. It is main system memory connected to South Bridge via a PCI bus that is 33 megahertz in this diagram. Again, coming to the diagram. So you can see HDRAMs is there. So definitely it is connected to the North Bridge, and North Bridge is connected by a, again, this South Bridge via this PCI bus, PCI 33 megahertz bus, right? Because means it is in PCI protocol is in very complex kind of things. Why we need this RAM, right? Why we have access from the South Bridges just for now, because we have some IO devices, so we have some transactions model, right? So to understand that which kind of device is connected, we have some internal register space, and also we also need some memory over here. So in coming sessions we will discuss about all these things. So after that only you will comes to know the purpose of the each and every block. But just for now, we at least minimum we need to understand the connectivity, why and how they are connected. uh, Next one is IDE. Might be hard disk, might be compact disk. Connects to storage devices like hard disk and optical drives, means CD, DVD, something like that. Next point, connected via, again, IDE. IDE stand for integrated drive bus, to drive some data only. Next point is IDE is managed by Southbridge. Fine. Now, again, coming to the main diagram, here you can see some CD, HDD, these blocks are connected via IDE bus towards the Southbridge. Fine. Now let's take USB ports. Again, universal interface for peripherals. That might be mouse, printer, keyboard, and something else you want to connect, right? Next point is managed by Southbridge. Coming to the diagram, here you can see Southbridge. So again, USB port is connected. So you might have one question that here we have the USB port for like keyboard, printer, and mouse. So then why we have keyboard and mouse port over here? Because uh, that is a block something called super IOs. Because you can see in previous time the every PC, every CPU has some dedicated port for aux, for mic, right? Audio, video, and all. So at that time, keyboard with the USB and mouse interface was not available. But nowadays, even your audio port is also available with the USB port, right? Audio port means you can talk, you can listen, all these things can be connected with the USB ports. So we have all the things over here. If you have outdated kind of things, you can connect here super IOS port, else directly you can interface with the USB port. After USB ports, let's come to the Ethernet. Ethernet and SCSI. So we all know what is Ethernet, but first SCSI, what is that? So it stands for small computer system interface. Used for connecting and transferring the data between computers and peripherals. Peripheral devices like again some HDD, tape, because we internally we have some HDD or hard disk, or nowadays SSD is available, but externally we can also connect. And for more some backups, obviously if you can connect some hard drive or SSD or USB drive from outside, so obviously you are talking about the backups and servers, right? Network and high performance device interface, because Ethernet is there, so definitely we are talking about the network. Controlled via Southbridge, connected by PCI bus. Fine. So again, here the Ethernet and SCSI ports are there, which is connected to PCI bus, and via PCI bus it is connected towards the south bridge as well as the north bridge. Now next point. What is ISA bus and what else? We have that ISA and let's talk about peripherals, all these things. ISA bundle, bus and peripherals. So again, ISA stand for industry standard architecture used for older, or we can say legacy devices in old generation PCs, right? Devices include boot ROM, uh, some modem or audio chip, like keyboard, mouse, and super IOs. So all these things are connected with the IS. Here we can see, right? So that is the ISA, and this block is also super IO is also connected with this ISA bus, right? So just few words regarding that. Boot ROM contains firmware for startup. After that, some modem or audio chips, simply communication and for audio devices. Keyboard, mouse, we already know. Input devices. Again, super IOs manage some serial ports, parallel ports, and floppy drives. Fine. Here. So we have, lot of option we can connect over here. In old generation PCs nowadays directly we can give anything from USB interface. What we can give, some audio device, right? Means audio means mic as well as the speaker, means sound in as well as sound out, keyboard, mouse, our input devices, some flash drives, hard disk, right, printer, all the things we can connect from over here. Some modem we can also connect. So in a simple summary, in a single line, summary of flow. So first of all is CPU. Fine. CPU will communicate with North Bridge. It will communicate towards HDRAM and graphics. Then North Bridge communicates with South Bridge. Fine. So guys, if you have any kind of doubt, fine. So guys, if you have any kind of doubt, anything, so you can make the comments. By next session, we will take the comments and we'll explain the things. Thank you.